Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the production or generation of X-rays. X-rays are produced by an X-ray tube. The schematic of the model type of X-ray tube is shown in the below figure. Okay, X-rays are produced by X-ray tube. We are going to use X-ray tube. By using X-ray tube, the X-rays are produced. We can see in this diagram we have transformers, rectifiers, resistors, okay, target area, and the red color region, right, that is called X-ray tube. By using inside that X-ray tube, the X-rays will be produced. We are having the cooling water area, okay. While we have a target place, right, when the supply is given through the transformers, the supply will be passed on to the rectifiers, and from there the rectifier is connected to the resistors. The resistors will be connected to the another coil. We have coil and the resistors are connected together, right? We have coil over there. This coil, from this coil will when the supply is given, this coil will produce a electron beam that will be passed on to the target. From the target will produce the X-rays will be produced, okay. The tube, we can see the red color area, right, that is called X-ray tube. X-ray tube. By cooling water is added, right, by cooling the tube, the cooled X-rays will be produced. The cooling water is to cool down the X-ray tubes, okay. It is an evacuated glass bulb enclosed 2 electrodes, cathodes and an anode. As I told you, we have that red color region I have showed you, right, that is called a glass bulb enclosing 2 electrodes, cathode and an anode. The cathode consists of a tungsten filament which emits electrons when it is heated, okay. Cathode consists of tungsten filament which emits electrons when it is heated. The electrons are focused into the narrow beam with the help of a metal cup S, okay. This is a metal cup. It is a narrow beam, right, metal cup S, coiled with a metal cup S. The anode consists of a target material made up of tungsten or molybdenum. Anode consists of a target material made up of tungsten or molybdenum which is embedded in the copper bar. As I told you already, we have transformers which is connected to the rectifiers. The rectifiers are also connected with the copper bar, right. That copper bar is connected to an anode. That material is made of tungsten or molybdenum. Water circulated through a jacket surrounding the anode and the anode and cools the anode, which is used for the cooling water is, right. The cooling water is used to cool down the anode. Further, large cooling fins conducts the heat away to the atmosphere, okay. While the water is circulated, the heat will be move on to the atmosphere. Next, the face of the target is kept at an angle relative to the oncoming electron beam. The face of the target, right, the target will be in this condition, this way, straight way, and the face of the target where the electron beam going to hit, okay, that will be just opposite to the beam, which is from where the beam is going to be passed. The face of the target is kept at an angle relative to the oncoming electron beam. It will be in the slight modification of 45 to 50 degree. Okay, a very high potential difference of an order of 50 kV is applied across the electrons. Okay, a high potential difference of the order of 50 kV is applied across the electrodes. The electrons emitted by the cathode are accelerated by anode. Electrons emitted once the supply electron beam hits the target, the cathodes are accelerated by the anode and acquires high energy of the order of 10 to the power 5 electron volts. Okay. Whence the electrons emitted from the cathodes are accelerated by the anode and acquires a high energy of order of 10 to the power 5 electron volt. When the target suddenly stops these electrons, electrodes or X-rays are produced. Okay, we have cathode and we have anode here. Once the supply is given, okay, the electron emitted from the cathodes are accelerated by the anode and acquires a high energy of 10 to the power 5 electron volt. When the target, anode is here and cathode is here, when we have the cathode in between the anode and cathode, these electrons will suddenly stop by the target and the X-rays are emitted. Okay, the magnetic field associated with the electron beam undergoes a change when the electrons are stopped and the magnetic waves in the form of X-rays. Okay, magnetic fields associated with the electrons undergoes a change in the electrons while the electrons are stopped by a target. Okay, by that way X-rays are generated. Next, the greater of the speed of electron beam, the shorter will be the wavelength of radiation, X-rays. Okay, as the speed is greater, electron beam speed is greater, the wavelength of the X-ray radiation will be very shorter. Only about 0.2% of the electron beam energy is converted into X-rays. Okay, only 0.2% of electron beam energy is converted into X-rays and the rest of the energies are transformed into heat. Okay, as the speed of the electron beam is greater, the wavelength will be very shorter, which will be of about 0.2% of electron beam energy, and the remaining energy will be converted, that 0.2% of energy will be converted into X-rays and the remaining energy will be transferred into heat. It is for the reason that the anode is intensively cooled during the operation of X-ray. Okay, the anode is continuously keeping cooled by the cooling water. Okay, that is why the X-rays, the percentage of the conversion of X-ray is very minimum. The intensity of the electron beam depends on the number of electrons leaving the cathode. The hardness of the X-rays emits depends upon the energy of electron beam strikes the target. Okay, as I told you already, it depends on the area or a place which we are going to scan. Okay, whether it may be the soft tissues or the hard tissues. According to that, the radiations will be passed, and according to that, if the radiation is high, the strike rate will be the target strike will be larger, and the X-ray produced will be of larger percentage. Okay, thank you.